What you are looking at is probably a series of rocks, but that's not what I am seeing. In these rocks, I can see some beautiful ornaments, swanky cars, strong containers and some high-rise buildings. Am I getting poetic, or is there chemistry in what I am saying? Join me in the studios and we shall discover the answer together. Welcome to today's show. It was a small nail like this one that got me thinking that had it not been for metallurgy, then building ocean liners, machines and bridges would have been impossible. After all, it was the science of extraction that made the invention of the nail possible. It's clearly a topic worth studying, and so today we will learn how metals occur as minerals in nature and understand metallurgy. We will also study metallurgical processes like concentration of ores, roasting and calcination, reduction and refining. And finally, in Exam Decoded, we will look at how to write those perfect answers. Looking at rocks, it is hard to imagine that they hold a metal inside them that shines and has luster. But then, metals are rarely found in a pure state in nature. Most often, metals exist in combination, that is, as compounds of oxygen, carbon or sulfur in rocks that are known as minerals. For example, iron is found in various combinations like magnetite, which is iron oxide, siderite, which is iron carbonate, pyrite, which is iron sulfide. Magnetite, siderite and pyrite are all minerals that are mined for procuring the metal iron. At the beginning of the show, I had mentioned another word in conjunction with minerals, and that was ores. And that is because ores are minerals with substantial amounts of metal in them that can be easily and profitably extracted. An example of an ore is hematite or natural ore, that is an iron ore. In your exams, you can be asked to state the ores of various metals along with their formulae. So why don't you note them down as I take you through some important ones. Aluminium is the most abundant metal in nature and is usually extracted from an ore called bauxite. Copper exists as copper glans, copper pyrite and malachite. Zincite and calamine are ores of zinc. The common ore of mercury is cinnabar, chromium is found as chromite and tin as cassiterite, and manganese is usually extracted from meganite. Now, all the ores that we have been talking about contain a lot of impurities known as gangue. And so, the first step towards extracting metals is to remove these impurities. In other words, the desired metal needs to be concentrated away from the impurities. In metallurgical parlance, this process is called concentration. Concentration is also known as dressing or benefaction. In order to facilitate concentration, the ore is first crushed using a grinding mill. Once the ore is fed into the grinding machine, it is pulverized to powder in it. It is this fine powder that is treated to remove the gangue. The process of concentration can be carried out by a number of methods based on the difference in density, magnetic properties and selective solubility of the ore and the gangue. Amongst these, the separation by density method is most commonly used for metals. Known as hydraulic washing, in this process, ores are processed from gangue based on the difference in their densities. Before I tell you the details of the process, let's look at a simple lab experiment that illustrates the working principle behind hydraulic washing. If you were to take a mixture of sand and small stones on a sloping base and passed a stream of water over it, you would observe that while the sand gets washed away, the heavy stones stay as it is. This is because higher density particles are pulled to a greater extent by gravity as compared to lower density particles. As a result, the two can be easily separated. In hydraulic washing too, a stream of running water is used to wash off lighter gangue particles, leaving the heavier ore behind. The next method of concentration that we are going to discuss is called magnetic separation, and I am sure that you have guessed by now that it exploits the difference in the magnetic properties of the ore and gangue, and also that it is best used for iron ores. In magnetic separation, the ground ore is carried on a conveyor belt which passes over a magnetic roller. Since the magnetic roller attracts the magnetic ores, the non-magnetic gangue is easily separated. Having studied the differences in density and magnetism as criteria for concentration, it is now time to look at solubility. The difference in solubilities of the ore and the gangue is best utilized in the case of sulfide ores, as they dissolve in pine oil and their impurities do not. Known as froth flotation, in this process powdered ore is mixed with water and pine oil and churned with a blower. The ore then forms froth and floats on the surface while the impurities settle down. This lighter froth is then skimmed off and dried to recover the ore. Now, it is important for you to note that froth flotation is not the only method of concentration based on solubility. Leaching is the other method, wherein the ore is dissolved in a solvent while the impurities remain undissolved. Since a simple experiment in the lab can give you insight into this process, let's observe one. If bauxite ore is dissolved in sodium hydroxide, the ore dissolves as aluminates and the impurities settle down and are separated thereafter. The sodium aluminate solution is then diluted with HCl to form aluminum hydroxide, which in turn separates from the solution as it precipitates out. Application of high heat then converts the hydroxide into pure oxide by evaporating the water. By now you have learned the various methods to extract metals. But do you know which metal is the miner's joy in terms of abundance? I'll leave you with a hint. This metal is extensively used in space and auto industry. Keep thinking while I take a short break. Welcome back to our episode on metal occurrence and extraction. In case you have found the answer to my question about the metal that is extensively used in space and auto industries, you will make profits in the exam and your life. The answer to my question is aluminium, which is the most abundant metal on earth. And if you want to know more such facts of science, then log on to our website www.topperlearning.com. Having studied about grinding and concentration before the break, it is time now for us to move on to the next step in extraction, which is that after an ore is concentrated, it is converted into its oxide. The conversion to oxide can be carried out by two methods: calcination, that is heating in the absence of air, and roasting, that is heating in the presence of air. If an ore is rich in oxygen, like a metal carbonate or a metal sulfate, it is heated in the absence of air. Calcination normally takes place at temperatures below the melting point of the product materials, because if heated beyond melting point, compounds other than oxides may be formed. On the other hand, ores like sulfide are roasted, that is heated in presence of air to convert the ore into its oxide. This oxide form of the ore is then heated strongly so that all volatile impurities are also removed. In your exams, if you are asked about the usage of the byproducts of roasting, you can quote the example of sulfur dioxide, which is used to manufacture sulfuric acid. The next step in line is reduction, because when a metal forms an oxide, reduction aids in retrieving the metal by removal of oxygen. If you are the kind of person who looks beyond the obvious, then you would question the step that I have just described. Why I am saying so? Listen to this query by a fellow student and you will find out.
Some metals are good reducing agents themselves. So how are they reduced?
See, there was a contradiction waiting to be caught. Metals which are good reducing agents themselves are reduced by more reactive metals like magnesium or aluminum, and highly reactive metals like sodium, potassium and calcium are reduced by electrolysis. Having resolved that query, it's time now to scrutinize the end product of reduction. The reason being that though reduction helps in obtaining free metals, there is a possibility that other impurities might still exist. For example, while obtaining copper from copper pyrite, iron also gets separated along with copper, and so it is considered an impurity. The process that removes such impurities is known as refining. Now, like in concentration, there are several methods to refine metals. Of these, the liquation method uses the difference in the melting points of the metals and its impurities. Metals with low melting points like tin, lead and bismuth are easily refined by using this method. In this method, a block of impure metal is placed on a sloping furnace. The required metal melts on heating and flows off the slope where it is collected for cooling. In case the melting point of the impurity is lower, then it flows off, leaving behind the desired metal. In case of metals with a difference in volatility from their impurities, the distillation method is adopted. This method is usually used for metals like zinc, cadmium and mercury that vaporize easily. As part of the distillation method, a block of impure metal is first heated and then its vapors are condensed and separated in a container called receiver. This leaves the non-volatile impurities behind in the distillation chamber. However, the most common method that is used for refining metals is known as electrolytic refining. This process uses a special electrolytic cell that is constructed with the impure metal as anode and a thin strip of the pure metal as cathode. The electrolyte used in this cell is a suitable metal salt of the metal to be refined. When an electric current is passed through this electrolytic cell, ions from the anode enter the electrolyte and the same number of metal ions from the electrolyte gets deposited on the cathode. As the reaction proceeds, the anode becomes thinner and the impurities either remain in the electrolyte or get deposited below the anode as what is known as anode mud. And in case some important metals like gold and silver are present in the anode mud, they can be recovered separately. Now, though the electrolytic method is used for most metals, ultra-pure metals needed in semiconductor industries and space applications are refined by Van Arkel method. In this method, metals are converted into metal iodides which can be easily decomposed to extract the highly pure form of the metal. In the Van Arkel refinement of titanium, a block is heated with iodine at a temperature of 250 degrees Celsius. Titanium then converts into titanium tetraiodide, but the impurities do not. This titanium tetraiodide is then passed over a hot tungsten filament so that titanium tetraiodide is decomposed and ultra pure titanium is obtained. Like heating, cooling also helps in refining metals. Zone refining is one such method where a metal is crystallized on cooling and its impurities are automatically expelled. For example, germanium. In the zone refining of germanium, impure germanium is made into a rod. Then a piece of ultra pure germanium metal called seed is attached to the rod on the left hand side. A circular heater is then moved over the length of the rod. As a result, the germanium seed and the impure germanium rod melt. As the heater is moved away slowly, the temperature drops and the germanium from the rod recrystallizes, thereby expelling the impurities. You must note that as the heater moves in one direction, the ultra pure germanium moves in the opposite direction. I am sure that by now you know why I saw so much chemistry in rocks at the beginning of the show. This also means that the learning is over and the application of the information gathered must begin. That's right, it's exam decoded next, but after this break. Welcome back. Ready to extract the best for your exam preparation? Then let's concentrate the key learnings of today and head straight for exam decoded. In today's episode, we have learned that ores are minerals from which extraction of metals is cost effective and viable. We also learned that the steps involved in extraction of metals from their ores is called metallurgy. Impurities in ores are called gangue and are removed by concentrating the ore. Concentrated ores are converted into their oxides by calcination, that is heating in absence of air, or roasting, that is heating in presence of air. Oxides are reduced to metals and then refined further to get the pure metal. I am sure now you are ready to mine some good marks. So let's get going. Welcome to Exam Decoded, where I will help you refine your preparation to help you get the best scores possible. First up is the rapid fire round with 5 questions to be answered in 5 seconds each. Each right answer will get you a mark and I expect you not to fudge the scores. So are you ready? Your first question is: hematite is an ore of A. Iron, B. Copper, C. Zinc, D. Mercury. And the answer is A. Iron. Your next question is: aluminium is the most abundant metal on earth. True or false? And the answer is true. Now the third question is: froth flotation is a method of concentrating A. carbonate ores, B. sulfide ores, C. oxide ores, D. chloride ores. And the answer is B. sulfide ores. Your fourth question is: unwanted impurities in an ore are called gangue. True or false? And the answer is true. Unwanted impurities in the ore are called gangue. Your last question for this rapid fire is: which of the following method is used to remove heavier gangue particles? A. magnetic separation, B. hydraulic washing, C. leaching, D. froth flotation. And the answer is B. hydraulic washing method, which is used to remove heavier gangue particles. So how did it go? If you got all 5 right, then great, you are our topper high flyer. If you got 3 or 4 answers right, you are an achiever. Revise your basics and you do better. If you got less than that, you could do with all the practice and revisions you can get, and our website www.topperlearning.com has all that and more, so make it a point to visit the website. The topic Occurrence and Extraction belongs to the unit that carries a weightage of 3 marks and is important from the exam point of view. Questions asked from this topic are usually short answer type questions of 2 or 3 marks that will test your knowledge ability. Why don't I solve the 3-mark question for you and show you the ideal way to approach the answer so that you can get those ideal marks. You must begin the answer by stating the significance of leaching, which is that the aluminium ore bauxite is leached to remove insoluble impurities like silica and ferric oxide. This much will get you 1 mark. To explain the process of leaching, state that it is carried out by dissolving the powdered ore with a concentrated solution of sodium hydroxide. You must also state the reaction for this. The answer up till this point will get you 1 more mark. For the remaining 1 mark, you must write that since the alumina dissolves in sodium hydroxide, the impurities that are left behind can be filtered out easily. The aluminate solution that is remaining is neutralized with carbon dioxide gas and the hydrated Al2O3 is precipitated from it. This hydrated alumina is filtered out, dried and heated to give the desired pure Al2O3. With the ideal answer done, it's now time for our exam expert who will give you some more inputs on preparing this topic for the exams.
Occurrence and extraction of metals, which comes under metallurgy, you should all know what is mineral and what is ore. What is the difference between the two? What are the different types of ores? The different methods or steps of concentration, which are like calcination, roasting, reduction and refining. If you know the principles of all the processes involved, you can easily learn the equations. But the key tip here I would like to give is that practice and practice more for equations, because it is just practice that will take you to a longer stride.
Today you have learned that metallurgy is the science of extracting metals, but you must also remember that practice is the art of extracting good results. So concentrate on the facts, reduce your stress and refine those results. Good luck and goodbye. In the days of fast food, pizzas and burgers, I remain a man fond of old-style Indian cooking. Take this biryani for example. This has been cooked in a special copper vessel called deg. Have you noticed the restaurant has served water in a copper glass too? Why is copper being used here? Are you thinking what I am thinking? There is chemistry at work on this dining table. Join me in the studio and you will find out. Welcome to the show. I am sure you must be thinking that I see chemistry in everything, even while eating. But then the copper vessels being used caught my attention because they are the perfect example for what we will study today. In today's episode, we will study thermodynamic principles involved in the reduction of metal oxides, Ellingham diagram to predict the choice of reducing agent, electrochemical principles involved in reduction of metal oxides, and finally there is the exam decoded segment where I will tell you how to prepare smart for your exams. From the insides of your computer to the staple pins you use to the car that you travel in, metals have become an indispensable part of everyone's lives. Today I will take you through the journey of these metals, from being a part of a nondescript rock to a form in which all of us utilize these metals. In other words, today we shall learn what metallurgy is all about. Metallurgy is the branch of science and technology concerned with the properties of metals, their purification and production. Now, as you are aware, metals exist as minerals in nature, and minerals from which metals can be extracted profitably are known as ores. Ores occur in nature as metal oxides, metal carbonates and metal sulfides. And as you are aware, in order to extract the metal from its ore, it is first pulverized and then concentrated to remove impurities. The concentrated ore is roasted in air or calcinated in absence of air to convert the ore into its oxide. The next and the most important step is reduction of the oxide into free metal by using a suitable reducing agent. As you can see, reduction is an extremely important part of retrieving metals in a usable form. As students of chemistry too, the process of reduction of the concentrated ore is important because it is governed by two fundamental principles, thermodynamics and electrochemical principles. I think it would be a good idea to revise some key terms of thermodynamics at this point, which are enthalpy, entropy and Gibbs free energy. This is because these parameters will help us in identifying whether the reduction reactions will be feasible or not. Enthalpy change is the measure of heat change of a reaction at constant pressure, denoted by delta H. N means from within, and thalpane in Greek means to heat. Entropy is the measure of disorder of a system and is represented by ds. However, these two parameters are not sufficient. Gibbs free energy is the maximum work that a system can do and is represented by G. Mathematically, free energy change delta G is calculated by enthalpy change delta H minus product of temperature T and entropy change delta S. The feasibility of any reaction can be expressed in terms of its spontaneity. A reaction is spontaneous if delta G is negative and vice versa. Why don't you take a look at a diagrammatic representation of this for a better understanding? As you can see, rolling a boulder uphill involves overcoming resistance and is certainly not spontaneous like a boulder rolling down the hill. You would require more energy to get the boulder up than down, and when there is balance, then there is a state of equilibrium. This brings us to an important learning point, the Ellingham diagram. The Ellingham diagram is a plot of the free energy of formation of a metal oxide per mole of oxygen against temperature. As you can see, each line represents the reaction of the metal with 1 mole of oxygen. The most reactive elements, that is the ones with the most stable oxides, are at the bottom of the diagram. In general, with metal oxides, when the temperature increases, the negative absolute value of the Gibbs energy of formation will be smaller. This makes the oxides unstable and easy to reduce, with the exception of carbon monoxide, which is a good reducing agent at low temperature. A metal oxide can be reduced easily when it is unstable, and the Ellingham diagram that you just saw can be used to predict the reducing agent and the temperature for the reduction of a given metal oxide. Let's begin with the least stable metal oxide, that is copper oxide. On looking at the graph, you will see that it is placed at the top, which means that the oxide is unstable. Since the lines of C and CO are below it in the graph, copper oxide can easily be reduced by heating with coke. However, it has been observed that the ore of copper, that is copper sulfide, when roasted changes to copper oxide, and as this oxide is highly unstable, it readily reacts with unoxidized ore and is reduced to copper. So you must remember that copper oxide can be reduced with or without coke. The process that I just described is called Bessemerization, and after the reaction is completed in the Bessemer's converter, molten copper is poured off and the byproduct sulfur dioxide, as shown in the equations, bubbles out. Today's show began with a conversation on copper, and it's quite interesting that it's time for the first break right after our discussion on copper itself. And since the pattern is set, during the break I want you to find out for me what blister copper is. Keep thinking and I'll be right back. Welcome back. I think by now you must have figured out the answer to the question I had left you with, what is blister copper? The clue to the answer lies in the Bessemerization process that we have just learned. When the sulfur dioxide bubbles through the molten copper, it forms blisters on its surface, and as a result, the copper collected is called blister copper. Now, if you want to sharpen your problem solving skills by answering more questions like this one, then do log on to www.topperlearning.com. Well, after Bessemerization of copper, we will now look at another fascinating process known as smelting. This reduction of iron oxide with carbon in the blast furnace is called smelting. In smelting, iron oxide is heated with coke and lime in a furnace called blast furnace because heating is done in it by a hot blast of air. The carbon in coke reduces the FeO and will itself be oxidized to CO. Likewise, Fe3O4 and Fe2O3 are reduced at relatively lower temperatures by CO. In the blast furnace, the reduction of iron oxide takes place in the upper part of the blast furnace in what is the lower temperature zone, and in the lower part of the furnace at higher temperatures carbon reacts with carbon dioxide to form carbon monoxide. I firmly believe there can be no learning without asking, and so I am very glad when students ask me their doubts, because it means they have been paying attention and thinking for themselves, just like this student.
Sir, I wanted to know if lime is used as a flux in all metallurgies.
No, it isn't. In fact, the flux is chosen depending on the nature of the earthy material present as impurity. If an acidic impurity like sand is present, then a basic flux like lime is used and the slag formed is CaSiO3 or calcium silicate. If there is a basic impurity like lime, then an acidic flux like sand is added and the slag formed is the same, that is CaSiO3. I hope the criteria for choosing a flux is clear to you. So far we have seen the reduction of copper and iron, but I would also want to talk about zinc. In the Ellingham diagram, zinc is below both carbon and carbon monoxide till a very high temperature. As a result, zinc oxide is reduced with carbon at a temperature higher than that for copper oxide and iron oxide. The procedure for reducing zinc oxide entails its conversion into briquettes with coke and clay. On heating these briquettes, carbon monoxide is released. Since the metal formed is volatile, it is distilled and thereafter condensed for usage. I am sure by now you must be wondering how stable oxides are reduced. Once again, we shall return to the informative Ellingham diagram for some answers. As you can see, oxides of magnesium and aluminum are most stable, and this can be inferred from their position at the base of the graph. Also, since these oxide lines are much below that of carbon and carbon monoxide, they cannot be reduced with coke. Clearly, a heat base, that is thermochemical principle, is not very practical for reduction of these oxides. As a result, an electrolytic method needs to be adopted. You are aware that the tendency to add electrons is measured as the standard electrode potential, which is related to Gibbs free energy by the expression delta G is equal to minus NF E naught. Since more reactive metals have large negative values of delta G naught, so their electrode potential is also high. As a result, their reduction is possible using electrical energy. In order to facilitate electrolytic reduction, a cell is constructed where the concentrated ore is used as the electrolyte. When the current is passed, the metal ions from the electrolyte get reduced by accepting electrons. Let's look at a cell constructed to reduce aluminum oxide to get a better understanding of this concept. The electrolyte of such a cell is Al2O3 mixed with cryolite Na3AlF6. Since solid Al2O3 is not a conductor of electricity, cryolite is added to lower the melting point of Al2O3. The cell is lined with carbon that acts as cathode, and a series of carbon rods are placed which act as anodes. When electrical current is passed, aluminum metal is released at the cathode and oxygen is released at the anode. This oxygen then reacts with carbon anode and carbon dioxide is released. Pure aluminum, being heavier than the electrolyte, collects at the bottom of the tank. The aluminum is then drained off and purified. It's time now for a break, but do join me for the next segment because we are going to be taking on exam questions from this topic in Exam Decoded. See you in a while. Welcome back. We have been talking about the thermodynamic and electrochemical principles of metallurgy. And here are some of the important points from our discussions. In this episode, we have learned that the Ellingham diagram plots the free energy of formation of a metal oxide per mole of oxygen against temperature. This is used to predict the reducing agent depending on the stability of various metal oxides. Metals which form stable oxides are good reducing agents like magnesium and aluminum. Reactive metals have large negative values of delta G naught are reduced by electrolytic methods. Let us now tackle the possible exam questions from this topic in the exam decoded. Welcome to exam decoded, where you will get all the help you need to maximize your scores in the exams. In this round, I will be asking you 5 questions related to what we have learned today. You have 5 seconds to answer each one, which is worth 1 mark. At the end of the round, I will take stock of your scores and help you interpret them. Shall we begin? Your first question is, aluminium cannot be reduced with carbon as the reducing agent. True or false? And the answer is true. That was an easy beginning, wasn't it? Let's move on to the next one. In the blast furnace, carbon monoxide reduces iron at A. Low temperature, B. High temperature, C. Room temperature, D. Standard temperature. And the answer is A. Low temperature. Here is the next question. Flux fuses with earthy materials to give slag. True or false? It's true again. Moving on to the next one. Which of the following metals is used as a reducing agent? A. Copper, B. Zinc, C. Aluminium, D. Iron. The correct answer is C. Aluminum. Now the last question. Reduction of copper sulfide is done by A. Smelting, B. Bessemerization, C. Electrolytic reduction, D. Distillation. And the answer is B. Bessemerization. Time now for your scores. If you have got all 5 right, congratulations topper high flyer, you are on the top of metallurgy. If you got 4 or 3 questions right, you are an achiever and you are nearly at the top. So keep it up. If you have scored any less, then it's not too late. Catch up on those revisions and practice by logging on to our website at www.topperlearning.com. The topic Principles in Metallurgy belongs to the unit General Principles and Processes of Isolation of Elements and carries 3 marks, which means it is fairly important for your exams. Questions that appear from this topic usually test your knowledge ability and are usually of short answer type and very short answer type of 2 or 3 marks. Here I would like to give you some sample questions that you should revise. 1. What chemical principle is involved in choosing a reducing agent for getting the metal from its oxide ore? Consider the metal oxide Al2O3 and Fe2O3 and justify the choice of the reducing agent in each case. This question carries 3 marks. 2. Predict the temperature at which aluminium will reduce magnesium oxide. This question has a weightage of 2 marks. While it is important for you to know your facts, it is equally important to understand them and present them clearly. This demarcates a good answer from an excellent one. So let's attempt answering the 2-mark question that we just saw. The ideal way to answer this question will be to refer to the Ellingham diagram. You must state that on seeing the Ellingham diagram, which has the plot of delta G and temperature, it is easy to infer that up to 1350 degrees Celsius, magnesium oxide is more stable than aluminum oxide. This inference is made on observing that the line of oxide of magnesium is lower than that of aluminum. This much will get you 1 mark. At 1350 degrees Celsius, the line of oxide of magnesium cuts above the line of oxide of aluminum. Thereafter, aluminum will reduce magnesium oxide. This will get you the final 1 mark, taking your tally up to 2. That was how you should tackle such questions in the exams. For more helpful hints, let's go straight to today's exam expert.
In the topic Principles of Metallurgy, while preparing for your exams, students, you should remember the values of delta G, that is Gibbs free energy, given in Ellingham diagram are negative. So, lower the position of metal oxide in Ellingham graph, more stable it is. The choice of reducing agent depends on stability of a metal oxide. Carbon is the most commonly used reducing agent. You should know that electrode potential values can be determined from delta G. More reactive metals have high negative values of electrode potential, hence they are difficult to reduce.
I am sure you have made a note of all those very useful tips. Well, that brings us to the end of this session. Remember, for every minute spent in organizing the way you study, you earn an extra hour. Profitable, isn't it? See you next time. Hello, I am Devabrata Goswami and we are going on yet another exploration of the chemical world. Today's topic of discussion is one that has a far-reaching impact on many branches of industry, from agriculture to pharmaceuticals and yes, even in cooling. So, let's turn our attention to compounds known as polyhalogens and discuss some important examples like chloroform, iodoform, Freons and DDT. And then join me for Exam Decoded as I take a closer look at exam papers and give you insights on trends and probable questions. Polyhalogens are remarkable compounds with a wide variety of uses which are a result of their unique composition. They are essentially carbon compounds in which more than one hydrogen atom have been replaced with halogen atoms. If we take methane's example, two hydrogen atoms are replaced with chlorine in presence of sunlight or catalyst to get a polyhalogen compound known as dichloromethane. If we replace three hydrogen atoms with chlorine, then we get the compound that is commonly known as chloroform. Now, I am sure that when I mention the word chloroform, many of you will think crime thrillers and detective novels. But I am about to show you that it is a lot more than that. As we have just learnt, chloroform is formed when three hydrogen atoms in a methane molecule are replaced by three chlorine atoms. Chloroform has a tetrahedral structure where the carbon is bonded to three chlorine atoms and one hydrogen atom. Now that we know how it is formed chemically, let's take a look at how it is produced industrially in mass quantities. This is done by the action of bleaching powder on ethanol in an aqueous solution. Bleaching powder first converts the ethanol into acetaldehyde. This is then converted to trichloroacetaldehyde, which is also called chloral. Chloral, when reacted with lime water, gives calcium formate and chloroform, which is a colorless, oily liquid that is heavier than water and sparingly soluble in it. Chloroform is an excellent solvent and is used extensively in the pharmaceutical industry for producing dyes and pesticides. And of course, I am sure you are familiar with chloroform's most celebrated use as that of a local anesthetic. In 1847, Scottish physician Sir James Young Simpson discovered that chloroform has anesthetic properties and can be used in general surgery and even obstetrics. And although medical science has gone on to develop more sophisticated anesthetics, chloroform is still used in many dissection experiments. Which brings me to a question that examiners love asking. If you have noticed, chloroform is always stored very carefully in dark colored bottles. Why is that? Keep thinking. When chloroform is exposed to air in the presence of sunlight, it gets slowly oxidized into an extremely poisonous gas known as carbonyl chloride or phosgene. This is why it is stored in bottles where the darkened glass keeps it safe from air and light. Now I am wondering, could there be another way to prevent the harmful effects of chloroform? What if there was a way to get rid of the poisonous phosgene altogether? Well, why don't you think of how that can happen while I take a short break? Here is a helpful hint. Try searching for the answer on www.topperlearning.com. Then join me right after to check if you are correct. Welcome back to our session on polyhalogen compounds with me, Debabrata. Before the break, I had asked you to think of a way to remove the poisonous gas phosgene from chloroform to ensure a safer way to handle it. Well, phosgene can be removed from chloroform by adding a small amount of 0.6 to 1% alcohol. The alcohol reacts with phosgene to form the non-toxic compound diethyl carbonate, which is harmless. Now, let's talk about another polyhalogen compound that, by its molecular structure, looks very similar to chloroform. I am talking about the compound iodoform or CHI3. And just like chloroform was used for medical purposes in the past, so also iodoform was a popular antiseptic used to dress wounds and sores at the turn of the 20th century. This was because of the liberation of free iodine. But while iodoform had healing properties, it also let out a terrible smell that led to its gradual replacement by better antiseptics. Well, the medicinal use of iodoform may have gone out of style, but it still has other uses. And in order to study them, we need to first understand how it is formed. Iodoform is a compound that can be easily prepared in a lab. I'll show you how. Is also used to test the presence of aldehydes and ketones. These aldehydes and ketones have at least one methyl group attached to the carbonyl group. For example, CH3CO, or alcohols in which methyl group is bonded to the carbon bonded to the hydroxyl group. Compounds containing such functional groups react with iodine in the presence of sodium carbonate to form iodoform and the sodium salt of carboxylic acid along with other products. Now let's discuss what I consider one of the coolest polyhalogens. Speaking of cooling, have you been thinking about the question I had put to you right in the beginning? I had asked what specifically made air conditioners chill the hot air. The answer lies in a remarkable group of polyhalogens called freons. Freons have very low boiling points and are easily liquefied by applying pressure at room temperature. In an air conditioning unit, the compressor applies high pressure on the freon and liquefies it. When it moves to the low pressure area, the liquefied gas expands and absorbs heat from the surroundings and cause cooling. One of the most common freons in industrial use is dichloro-difluoromethane, also known as Freon 12. Freon 12 is prepared by the action of antimony trifluoride on carbon tetrachloride in the presence of antimony pentachloride. I am sure I don't need to remind you to study these reactions well. No exam is complete without a question asking you to state complete equations. It's time to take a call from one of our students.
Hi sir, I am Akash. I've heard that freons are harmful for the environment. Is it true? If it is, then how?
You have heard right. Unfortunately, for all its usefulness, freon leads to the depletion of Earth's protective ozone layer. When freons are released into the atmosphere, they mix with other gases and reach the stratosphere. Here, they get broken down by powerful ultraviolet radiations releasing free radicals of chlorine. The chlorine radical then reacts with stratospheric ozone to form chlorine monoxide radicals and molecular oxygen. This chlorine monoxide radical further reacts with atomic oxygen to produce more chlorine radicals. This constant regeneration of chlorine radicals leads to a breakdown of the ozone layer. The final polyhalogen compound on today's list is dichloro-diphenyl trichloroethane, more commonly known as DDT. I am confident that you are all very familiar with this compound. Yes, it is the insecticide widely used for killing mosquitoes and malaria prevention. Of late, DDT has been put under the scanner by environmentalists and health agencies. This is because DDT is not biodegradable and remains in the soil and on farm produce, which is consumed by humans. It has also been proved to be highly toxic and has therefore been abandoned in many Western countries. And here is one last important thing you must remember about DDT. Its IUPAC name, which is 111-trichloro-22-bis-p-chlorophenyl ethane. Don't get confused if this name is used instead of DDT in an exam question. In fact, I suggest you log on to www.topperlearning.com and revise all the chemical and common names of the compounds we have studied today. That reminds me, coming up next is a segment dedicated solely to ensuring your success in the exams. That's right, I am talking about Exam Decoded. Hi, I am Devbrata and today we are talking about polyhalogen compounds. Let's do a brief recap. We have studied that polyhalogen compounds are carbon compounds with more than one halogen atoms. Chloroform can be prepared by action of bleaching powder on ethanol and is used as a local anesthetic. Freon 12 is manufactured from CCl4 and antimony trifluoride and is one of the causes of the depletion of Earth's protective ozone layer. DDT is the common name for 1,1,1-trichloro-2,2-bis-P chlorophenyl ethane. I hope that revision has bolstered your confidence, because now it's time for exam decoded. Welcome to Exam Decoded, where we will demystify exam papers and give you all the tools you need to reach your goals. Before we get down to the business of dissecting question papers and discussing exam trends, let's play a game of rapid fire. This round has 5 questions, each of which must be answered in 5 seconds or less. Give yourself 1 mark for each correct response, and I will tell you what that implies at the end of the round. Simple enough? Let's begin. Your first question is, chlorofluorocarbon compounds of methane and ethane are collectively known as freons. Is this true or false? This statement is true. Question number 2 is, which of the following does not give the iodoform test? A. Ethanol, B. Ethanal, C. Propanone, D. Methanol. The correct answer is D. Methanol does not give the iodoform test, as it does not have a methyl group attached to the carbon bonded to the hydroxyl group. Your third question is, which one of the following is a correct combination? A. DDT coolant, B. Iodoform refrigerant, C. Freon antimalarial, D. Chloroform anesthetic. That is easy. The correct combination is given by D. Chloroform has anesthetic properties. The fourth question is, which of the following is not a freon gas? A. CCl3F, B. CF3Cl, C. CF2Cl2, D. CFCl2I. The right answer is D. This is your final chance to score. Complete the sentence. Chloroform is slowly oxidized by air in the presence of light to an extremely poisonous gas known as A. Carbon tetrachloride, B. Phosgene, C. Iodoform, D. Salicylic acid. The answer is B. Phosgene. I hope you all got it right. Well, let's see how well you did. If you have scored 5 out of 5, congratulations. You are a high flyer. This topic definitely holds the potential to get you top marks in the exam. If you got 4 or 3 on 5, you are an achiever. Anything below that means you are a learner. But do not worry, we have a handy helper for you, www.topperlearning.com. So log on and take all the tips you can get. And the tips continue right now with our detailed analysis of exam trends. The topic polyhalogen compounds is a part of chapter Haloalkanes and Haloarenes that carries a weightage of 4 marks, which makes it important. It's also an easy chapter to score, as you are most likely to get 2 to 3 mark questions that test your knowledge ability. In other words, get your facts right and you can earn those precious marks with no trouble. Here is a typical question that you could be asked for 2 marks. What is the iodoform test? We have covered this in detail in today's discussion, so let's begin with its definition. The iodoform test is used to detect the presence of aldehydes and ketones that have at least one methyl group attached to the carbonyl group. This test is also used to detect the presence of alcohols in which methyl group is bonded to the carbon bonded to the hydroxyl group. This part of the answer will fetch you 1 mark. Now give an example like ethanol will give the iodoform test. This earns you another half mark. For the remaining half mark, you need to explain the reason. So for ethanol, the reason is that it has the presence of CH3CHOH group. There are lots of other points to watch out for, and to tell you more, we have a very special expert joining us.
Polyhalogen compound is a very small topic towards the end of the chapter, haloalkanes and haloarenes. So generally students do not spend too much time on that topic. I'm not asking students to spend too much time on the same, but yes, students should quickly revise one method of preparation and any one use. There is a reasoning question from the same topic that why chloroform bottles should be filled till the brim and they should be stored in dark. Students should focus on that. Students should quickly revise the structure of DDT, its use. Also he should focus on says use of freon, methylene chloride, CCl4 chloroform.
It's time for me to say goodbye, but let me leave you with this food for thought. Although DDT was once a popular pesticide, its use has been banned in recent times. This is because DDT is extremely chemically stable and fat soluble. Why does that make it dangerous for living beings? Keep thinking. Let me end this with the words of a legendary scientist, Linus Pauling. Facts are the air of scientists. Without them, you can never fly. So I hope that you take all the facts you learned today and fly to bigger and better things. What do you think is common between the sugar we eat, the cotton we use for fabrics, and the paper that we use for writing? No, it's not just that they are usually white in color. They also have a chemical connection. What is that? Meet me in the studio to find out. Hi, I am Deobrata Goswami. Welcome to Chemistry. Today we will be talking about alcohols and the unlikely substances in which it can be found. In this episode, we will discuss the different methods by which we can prepare alcohols, especially the use of Grignard's reagent to prepare primary, secondary and tertiary alcohols. Then we will talk about methods by which we can prepare phenols. And finally, it's on to exam decoded. It can be quite amazing to know just how often we use alcohol in our daily lives. For instance, the ordinary spirit used for polishing wooden furniture contains alcohol. I think you can guess the answer to the question I asked you at the beginning of the episode. Yes, sugar, cotton and paper are all made up of compounds containing hydroxyl groups or alcohols. So, it is important to know how to prepare these compounds. You have learned that alcohols are formed when a hydrogen atom in a hydrocarbon is replaced by a hydroxyl group. But do you know that we can prepare alcohols by several methods? The easiest route to alcohols is to prepare them by hydrolysis of haloalkanes. When haloalkanes react with aqueous potassium hydroxide, the halogen atom X is replaced by the OH group and forms an alcohol. Alcohols can also be prepared by hydration of alkenes. Recall that alkenes are hydrocarbons with double bond and undergo hydration, that is, the addition of water molecule. In this reaction, alkenes react with water in the presence of acid as a catalyst to form alcohols. the addition of water to alkenes takes place in accordance with Markovnikov's rule. This rule states that the negative part of the adding molecule, which in chemistry jargon is called addendum, gets attached to the carbon atom which possess lesser number of hydrogen atom. For example, acid catalyzed hydration of propene forms propane 2-ol, which is in accordance with Markovnikov's rule. The hydroxyl group, which is the negative part of the addendum, is attached to that carbon of the double bond which has lesser number of hydrogens. Let us now study the mechanism of this reaction. In the first step, hydronium ion is formed which acts as an electrophile. Recall that an electrophile is an electron-seeking species. Hydronium ion attacks the alkene which gets protonated and forms a carbocation. In the second step, another water molecule reacts with the carbocation. Here, water acts as a nucleophile due to the presence of lone pairs of electrons on it. Recall that a nucleophile is an electron-rich species. The protonated alcohol which is formed gets deprotonated in the last step to form an alcohol. Besides the acid catalyzed hydration of alkene, alcohols can also be prepared by hydroboration of alkenes. In this method, alkenes react with diborane, a dimer of BH3, which is an electron deficient molecule. All the hydrogens of BH3 are replaced by alkyl groups to yield trialkyl boranes. These are then oxidized to alcohols on reaction with hydrogen peroxide in presence of alkali to form an alcohol. There is an important point to note here. If you see the formula of the alcohol so formed, you will see that the addition of water to the alkene has taken place according to anti-Markovnikov's rule. So, if propene undergoes hydroboration, it forms propane 1-ol, and if it undergoes acid catalyzed hydration, it forms propane 2-ol. Do remember this. You may be asked this in your exams. Is there any reagent which can be used to prepare primary, secondary as well as tertiary alcohols? Yes, we can do it with Grignard's reagent, which is represented by RMgX. Recall that carbon magnesium bond in Grignard reagent is highly polar, as carbon is electronegative relative to the electropositive magnesium. Due to this, Grignard reagents are very versatile reagents and are used in organic synthesis. But do you know how Grignard reagents are synthesized? Well, they are synthesized by adding organic halides to a suspension of magnesium in an ether-like diethyl ether. Let's see how primary, secondary and tertiary alcohols are prepared using Grignard's reagent. For preparation of primary alcohols, we react Grignard's reagent with formaldehyde to form an adduct which on hydrolysis gives primary alcohols. Recall that an adduct is a molecular entity which is formed by the direct combination of two separate molecular entities. Secondary alcohols are prepared by the reaction of any aldehyde except formaldehyde with Grignard's reagent. This leads to the formation of an adduct which on hydrolysis gives secondary alcohols. Tertiary alcohols are prepared from the reaction of ketones with Grignard's reagent. Here again we get an adduct which on hydrolysis gives tertiary alcohols. Now it's time for a short break, but let me leave you with a question. Give the name of an organic compound in which the hydroxyl functional group is attached directly to the benzene ring. You can look up the answer on www.topperlearning.com, and you can also get more information about alcohols. Stay tuned. Hi, welcome back. Before the break, I had asked you to name an organic compound in which the hydroxyl functional group is attached directly to the benzene ring. These compounds are phenols. They are simplest member of a family of compounds in which an OH group is attached directly to a benzene ring. Phenol is also known as carbolic acid, and it was first isolated in the early 19th century from coal tar. Phenols play an unseen but major role in our everyday lives. Plywood, windows, compact discs, computers, sports equipment and car headlights are some of the many items that rely on this important raw material. Let us now study the preparation of this important compound. In the laboratory, phenol is prepared by heating benzene sulfonic acid with molten sodium hydroxide at 570 to 620 Kelvin. A sodium salt is obtained which on acidification gives phenol. Phenol can also be prepared from chlorobenzene by heating with 10% sodium hydroxide at about 623 Kelvin and 320 atmosphere pressure. Note that copper is the catalyst in this reaction. Here it is very important to mention that sodium phenoxide is formed as an intermediate which yields phenol on acidification with HCl. This process is called Dow's process. There is another class of compounds which are commonly used in the synthesis of phenol. These are diazonium salts. To prepare diazonium salts, an ice-cold solution of aniline is taken in excess of dilute HCl. This is treated with an aqueous solution of sodium nitrite at low temperature of 0 to 5 degrees Celsius. This results in the formation of benzene diazonium chloride. Diazonium salts can be prepared in our lab. Let's see how. Take 1 ml of aniline in a test tube and add 2 ml of dilute HCl to it. Put it in ice-cold water so that the temperature is between 0 to 5 degrees Celsius. Add a 5 ml aqueous solution of sodium nitrite to it. The result is a diazonium salt. Phenol can easily be prepared by the hydrolysis of this benzene diazonium salt. Do you know that most of the worldwide production of phenol is from cumene, also known as isopropyl benzene? Cumene is prepared from benzene and propene in the presence of anhydrous aluminum chloride. Let us see how cumene yields phenol. First, in the presence of air, cumene is oxidized to cumene hydroperoxide. This, when treated with dilute acids, forms phenol and acetone. An important application of this process is that acetone is formed as a byproduct and is produced in large quantities. Well, I always tell my students that asking questions is the first step towards developing an understanding of a subject. Let's see what our young friend wants to know.
What is power alcohol?
Well, power alcohol is a mixture of 20% ethanol and 80% petrol and is used as a fuel in internal combustion engines to generate power. If you are looking for more answers or simply want to test your knowledge with more questions, log on to www.topperlearning.com. But now it's time for another break. Stay tuned because coming up next is Exam Decoded, your one-step guide to cracking the exams. Welcome back after the break. Today's episode has been an interesting one. Let's take a look at what we studied till now. Today we learned alcohols can be prepared by using hydrolysis of haloalkanes, hydration of alkenes, hydroboration, and from Grignard's reagent. Grignard reagents react with aldehydes and ketones to give primary, secondary and tertiary alcohol. Phenol is prepared from benzene sulfonic acid, chlorobenzene and benzene diazonium salts. Commercially, phenol is prepared from cumene. So that's in a nutshell. It's time now for Exam Decoded. Welcome to Exam Decoded, where we equip you with all the tools to maximize your scores. And what better way to begin than with an exciting round of rapid fire questions. Let me first tell you the rules. In this round, I will ask you 5 questions and you will have 5 seconds to answer each one. At the end of the round, we will tally your scores and see how you fared. Let's begin with the first question. Chlorobenzene can be converted to phenol by NaOH and copper catalyst at A. High temperature, B. High pressure, C. Low pressure, D. High temperature and high pressure. The answer is D. Chlorobenzene is converted to phenol by NaOH and copper catalyst at high temperature as well as high pressure. Next question. Grignard reagent gives tertiary alcohol when it reacts with A. Ketones, B. Formaldehyde, C. Aldehyde, D. Carboxylic acid. The answer is A. Grignard reagent gives tertiary alcohol when it reacts with ketones. The third question is, hydroboration of propene forms A. Propane 1-ol, B. Propane 2-ol, C. Pentane 1-ol, D. Pentane 2-ol. Yes, you are right. The answer is A. Hydroboration of propene forms propane 1-ol. Now the fourth one. In Dow's process, phenols are prepared from A. Chlorobenzene, B. Benzene, C. Sulfonic acid, D. Benzoic acid. The answer is A. In Dow's process, phenols are prepared from chlorobenzene. And now the last question. When benzene diazonium salts are reacted with water, what is formed? A. Benzene, B. Chlorobenzene, C. Phenol, D. Benzene sulfonic acid. The answer is C. When benzene diazonium salts are reacted with water, an organic compound phenol is formed. Here we come to the end of this round. Well, let me tell you your ranking. If you scored 5 on 5, it means you are a high flyer and are strong in the subject. Between 4 and 3 means you are an achiever, which is good, but a little more revision is still required. If you scored less than 3, you are a learner, but don't worry, for that we have more practice tests on our website www.topperlearning.com. So log on and improve your scores. This topic, preparation of alcohols and phenols comes under the unit alcohols, phenols and ethers. It has a weightage of 4 marks and is therefore important from our exam point of view. Generally, short answer type questions of 2 to 3 marks are asked from this topic. These questions test your knowledge ability. But no matter what you are asked, there is always a perfect way to answer it. Let's see what can get you full marks if you were asked this question. Write the reactions and their conditions for the commercial preparation of phenol from cumene. This question usually comes for 2 marks. Commercially, phenol is prepared from cumene. In the first step, cumene is oxidized to cumene hydroperoxide in the presence of air. This will fetch you half a mark. Writing the correct equation for this will fetch you another half mark. In the next step, cumene hydroperoxide, when treated with dilute acids, forms phenol and acetone. Writing this statement with correct equation will fetch you half mark each. Well, today's episode has been information packed, but now it's time to say goodbye. But let me leave you with some food for thought. What is wood alcohol and why is it called so? You can find the answer on www.topperlearning.com. Till then, it's Debabrata wishing you a confident time at the examinations. Keep smiling and keep thinking.